Hello and welcome back. Let's do a quick video here discussing how the lab works. In this current lesson, I'm having you basically re-download or rebuild your game file each and every time in these early labs. I think it's a little easier if you start fresh at the beginning of the lab. So these first three steps are what you've already done before. You copy and paste the code over to a text editor. You save it on your hard drive with a different name so you don't overwrite your old project. You make sure that your graphics file is downloaded, and then you run Firefox or Chrome and open and look at view your program. A little different in this lab is I want to make sure that you test it both under the arrow keys when you're using up, down, left, and right arrow to move the character, and test it under mouse control when you use the mouse to move the character. We're going to test under both conditions. Next up, inside of function start, which I'll show you in a little while, I just want you to do a console.log command and print the start of the game. Make sure that you know how to use the console. Remember, that's the Control-Shift-J command, brings up the console. The console is where you can print out error messages to help you debug your game. You can also see the error messages, and hopefully it'll give you a good error message and a line number where you can go fix your code. But make sure that you know how to use this console, and all I'm going to have you do is print a little startup message to this screen. Then there's going to be an update function, and in this update function, and it's new, I'll show it to you shortly, we're going to write 4 if statements. In the previous version of the game, we got the character moving about the screen. We got the animation working and the character moving about the screen. But what we didn't do is we didn't control or limit the character in any way. So let me pop up the previous version of the lab, and I'm under keyboard control now, and you can see if I go too far off the left side of the screen, the character disappears. If I go too far up the screen, the character disappears. And so on down the line. Everywhere I go, under keyboard control, the character could go off the screen. The lab assignment here is simple. We want the character to stop. When it hits the edge, stop. No matter how many times I hit the key, I should not go off the screen. Here I'm going off the screen. I want to control the X and Y coordinate so the character doesn't go off the screen. This is as far as I should get the character to move down into this corner. It should not go off the bottom of the screen. It should not go off the right of the screen. It should not go off the top or the left or right. Now that's under keyboard control. If I quickly switch over in my text editor and change, if I switch over in my text editor and I change the mouse back to true, remember, after I do that, I have to hit reload on my browser console. I'm back under mouse control. Now you'll notice the mouse control kind of self limits the character. The mouse only reports changes inside the canvas. So I can kind of go off the edge of the screen, but it's a little harder. Make sure you test this under keyboard control because there's some self-limiting here when it's under mouse control. See that top corner? That's the smallest position the mouse will report, so the character never goes off the left of the screen, never goes off the top of the screen. But you can go off the right and the bottom of the screen using mouse control. We don't want that. We want the character to stop here all the time, mouse or keyboard control. Now, how are you going to get it to do that? Well, you're going to write some if statements. When X gets too big, make sure that you change X so the character stays on the screen. When X gets too small, make sure that you change X so X doesn't go off the screen. Limit X to the smallest position of 0. When Y gets too big, change Y to a smaller value so the character stays on the canvas. And of course, when Y gets too small, make sure that Y gets adjusted. The smallest X a character should have is 0. The smallest Y a character should have should be 0. The maximum sizes are defined by the size of the canvas. Here we've got an 800 by 600 canvas. You're going to have to limit somewhere around that range, 800 and 600. You're going to have to limit X and Y changing. Do not let X and Y go past those values. And in fact, you're probably going to have to stop it before you get to those values. It's the bulk of this project. We're going to write those 4 if statements. Make sure that you test it under both keyboard and mouse control. Make sure that that character stays within the canvas. If it's falling off the screen, it's wrong. If it's staying on the screen, it's right. Now I think I have here a version of the game. This is mine. Okay, you can see it stops there. You can see it's not quite as limited as I wanted to. I want it to stop there. I let it go a little bit too far on that. So this is pretty close, but I'd rather the character stop right about there. Got it? It's not a hard one. I outlined this one in green so you can tell the difference between the 2 versions. This is after the code is done. My character never leaves the screen. Now, I'm going to ask you to do something that I normally don't do. Go ahead and use hard-coded values in your if statements. Go ahead and use hard-coded values for when x gets too large or when y gets too large. I want you to see the relationship between the canvas size and the values you use. We're going to change this later. We don't normally like using hard-coded values, but we're going to change it later. And right now, so use hard-coded values that reflect the 800 and 600, and we'll change it later in a future lab. So let's look at this code. You can see that the basic variable setup is the same. We'll be tweaking with that mouse value, setting it to true and false, and testing our code under both conditions, making sure x and y don't get too big or too small. I set the refresh rate on this version to 17. By the way, if some of these numbers look a little different than the ones you're looking at in the lab, don't worry about it. I'll update the video if I make major changes to the code, but sometimes I go in there and I tweak with the refresh rate, or I might tweak with the speed. If your numbers are a little different than mine, don't worry too much about it. But that refresh rate says 60 times a second. That's about as fast as you want. 17 is the smallest number you want to assign to refresh rate, and that says update the screen 60 times per second. While you're playing with this game, you might want to test with different values. Makes it a little easier to test if it's not changing so fast. Now here's some new code that I've added. This is the function start. You can see by the message it's called once at the very beginning of the game. All I want you to do is go inside this function. This is the code inside the function. Replace this line or add to it below this line some code to do a console.log. We want to be able to see your game starting up. Now I ran the version of this, and I believe if I control shift J, there we go. I've got a start of the game showing up. And that will only execute once at the very, very beginning of the game, and that's all we want to see it. Now if I hit reload again, it will update again. See that 2 right there? It printed start a game again. The start function, the start code here, executes one time at the beginning of the game, when the game is first loaded or when you hit refresh or reload on the browser. Add one line of code there. The bulk of the work here is going to happen inside function update. Inside function update, between these 2 curly braces, it's got to be between these 2 curly braces, I want you to write your if statements. It's going to take at least 4. If x gets too big, bring x back. If x gets too small, bring x back. And the same for y. Put your code in here to limit x and y so the character never leaves the screen. This is the only area where you should be changing code. You should not be changing the code anywhere else. This is where lab gets performed at. Tweaking with the variables and adding code to start and adding code to update. Now below the line is the game engine. A big goal for this class is for you to understand how game engines work. When you write a game using a game engine, you're partners. You do some of the code and the game engine does some of the code. I show you the code so you can get more familiar with how game engines work and how they interact with your code. I think I tweak with this. I think I've added these null variables. That's for future labs. Whether they're equal null or not in your code, that doesn't matter. That's for future lab. What I really want to show you here is this window onload. As I explained in a previous lab, this onload code runs every time the game starts up. And what I do is I initialize the game engine variables in here. I also decide based on the value of your variables whether we're going to do mouse or keyboard control. The new thing that's been added to this code is that command start right there. This says go and execute the start function. So once at the very beginning, when the game first loads, the start code will run. This is what we call a hook. The game engine is providing a hook to run your code at the start of the game. Also recall the set interval function is very important. Based on the refresh, it's going to repeatedly call move it. In this case, with the refresh of 17, 60 times a second, we're going to call move it, which means the move it function is going to run 60 times a second. Move it's job is to redraw the character. Here's some new code in move it. A call to update. Again, this is a hook to run your code. Now what you have to understand, if refresh rate is 17, then move it's going to be called 60 times a second. If move it is called 60 times a second, update is going to be called 60 times a second. You'll notice in the lab description, I did not ask you to put a console.log in here. And in fact, putting a console.log in the update code is probably a bad idea, especially if it's going to execute every time. Update is going to run every time the screen refreshes itself. So if we have a refresh rate of 17, update will run 60 times a second. That's why we don't want to put a console.log statement here. The other thing you got to understand about where update is called is keep in mind that move it is going to redraw the character at a new X and Y position. If during the execution of this game, mouse move was called to change X and Y, or key move was called to change X or Y, the call to update just before we draw the character means you have a chance to change X and Y. It means your code can limit the movement. Again, this is how a game engine and your code interacts. For example, the game engine is just going to go wherever the keyboard or the mouse says to go. If you, the game programmer, wants to limit it, that's why update is being called. It's your chance to change X and Y so that it goes where you want it to go, not where the game engine wants to go. So notice how update is called just before it redraws the screen with the X and Y. You get a chance in update to modify the X and Y variables. The rest of the code is pretty much the same as previous labs. If we're under mouse control, this code will control the X and Y coordinate. If we're under keyboard control, this code will control the X and Y component. There you have it. Pretty simple lab. Before the start of the game, your character could go off the edge of the screen. Boom, off the edge of the screen, off the edge of the screen. We do not want the character disappearing. By the end of this lab, the way it should work is your character should stop. It should stop here, it should stop there, it should stop there. This is the limit of your character movement. I want it to always appear on the screen. Whether you're under mouse control or keyboard control, make sure that character stays on the screen. Do not allow it to go off the edge of the screen like that.